Welcome to another episode of Tech Connect. Today we're diving into a fascinating project that's a true cross-pollination of programming languages. OpenLDK, a Java just-in-time, JIT compiler and runtime environment implemented entirely in Common Lisp. Now if you're thinking, wait, isn't Java like the complete opposite of Lisp? You're absolutely right. That's what makes this project so interesting. So, imagine you've got a Java application or a library, but you want to tap into the elegance of Common Lisp for your project. Striking that balance can be quite a challenge, but OpenLDK is here to bridge that gap. It translates Java bytecode into Lisp, which is then compiled into native machine code. In simpler terms, it allows Java code to run in a Lisp environment. How cool is that? Let's break down how it works. OpenLDK reads Java class and jar files and then translates them into Lisp code. Think of it as a translator that slowly converts the script of a movie from one language to another, except here, the movie is the source code, and the translation is taking it from Java to Lisp. The translated Lisp code is then compiled into machine code for execution. And to keep things really interesting, Java classes get mapped to Common Lisp Object System close classes. This means you can mix and match Java and Lisp code seamlessly. An interesting use case for OpenLDK is when you want to utilize a Java library in a Lisp-based workflow, but don't want to deal with the overhead of an entire Java runtime. It's like having a toolbox that lets you use a specific tool when you need it without dragging the entire shed with you. Now, I know many of you might be wondering, is this thing efficient? Well, let's be honest. OpenLDK is not designed to be a high-performance Java runtime. If performance is your game, you might want to stick with traditional Java solutions. OpenLDK aims to fill those specific niches where a common Lisp coder might just need a dash of Java functionality. And just so you know, OpenLDK is still in the early stages. Basic programs are operational, and it handles core aspects like runtime startup, class loading, and reflection. But don't expect it to fully support every Java feature out there. It's a work in progress. Kind of like a set of bleachers at a stadium. They're functional for sitting, but they're still under construction for the big game. Now, here's a fun example to illustrate how Java code translates into Lisp. Picture this Java class that simply adds two integers and prints "Hello World." It transforms into a Lisp code framework with method stubs. At runtime, when you call the add method, the compiler kicks in and generates machine code focused on that specific operation. It's a bit like a chef who has a recipe, but when they realize they need to adjust the dish, they improvise, all while staying true to the foundational flavors. For folks worried about debugging, OpenLDK has got some cool features. By tweaking the LDK debug environment variable, you can trace bytecode compilation, dump Lisp code before it's executed, or even start up a Slink server for more interactive debugging. Just imagine getting behind the scenes of your favorite movie to see how it all comes together. That's what this debugging can feel like. Before we wrap up today's episode, let's reflect on what OpenLDK brings to the table. It's not just about compatibility between Java and Lisp. It's about creating a space where programmers can leverage the strengths of both worlds. Whether you're a staunch Lisp lover looking to dip your toes into Java, or a Java dev curious about Lisp, OpenLDK opens doors for exploration. So what do you think? A bridge between two worlds? Or just a complicated way to get things done? If you've used OpenLDK or have any stories about resting with programming languages, we'd love to hear from you. Until next time, keep exploring the fascinating intersections of technology.